Hello students, welcome back into the another session of CS07 data structure using programming in C. As all of you know that we are discussing about unit number 2, that is sorting and searching, where we have completed with various sorting techniques like bubble sort, insertion sort, quick sort, bucket sort, merge sort, and it's time to discuss about selection sort now. But before starting the theoretical section of selection sort from previous sorting techniques, bubble sort and quick sort is most important sorting techniques as far as the examination point of view is concerned. So without wasting more time, let's start with the selection sort. As we have bifurcated our subject into the three subsections, that we'll discuss the theory first, then we'll go for the algorithm of the same, and based on algorithm we will implement the program, and with reference to all this we'll observe the output. So same strategy we are carry forwarding for our next sorting technique, that is selection sort. Selection sort is one type of an interactive sorting algorithm which use the technique called search and swap. Over here we have to clear the two words, what is search and what is swap. No doubt swap is now a common and the known word for all of us. Swap means interchanging the values, that is called as swap. Search means it's a technique which find out a specific value from the group of value, that is called as search. So this selection sort search for the specific value and it swap on a specific position. So it used the strategy called search and swap. Let me again revise the word which I have already instructed. Selection sort is an interactive sorting algorithm that use search and swap approach for sorting the collection of numbers. During the each pass of the collection, algorithm find out the smallest element to be sorted and swap with the first unsorted element into the collection. The algorithm continues in this manner, which find out the smallest element from the first unsorted value, and if it founds the smallest value, then the first unsorted value, then it simply swap these two values till the last two unsorted values. Once all the elements get placed on the specific position, user will find only the two unsorted value, and by just swapping, just comparing and swapping these two values, entire list of elements get sorted. So what we have to theoretically perform in this particular selection sort, first we have to enter any number of unsorted elements. Say for example, suppose I have entered these 5 unsorted numbers like 5, 0, 1, 3 and 7. This is unsorted numbers and total number of elements are 5. First, into the output, that means into the passings, I am keeping 5 as it is, and then I am comparing this 0 with 5. If I found 0 less than the previous value, we need to make a swap, and the remaining pass keep as it is. So the first pass of this selection sort is 0, 5, 1, 3 and 7. Again I will compare 0 with 5 So 0 is less than 5. Then I will compare 0 with 1. 0 is obviously less than 1. It is also less than 3 and 7. So pass number 1 is completed. Into the pass number 2, let me write over here pass number 1. That means repetition number 1. Pass means repetition. In my second pass, I will take the second value called 5 and I will compare with rest of the values. That means 5 is going to be compared with 1. So 5 is largest than 1. So instead of 5 there is 1 and 1 is replaced with 5. Rest it compares with the two more value, that is 3 and 7. So again 5 is larger than 3. So 3 will be kept over here and 5 will be replaced with 3 and 7 remains as it is, which is called as pass number 2. In pass number 3, it will check the entire list of elements whether any of the element is lesser than the previous one or not. So as far as our input is concerned, every previous value is smallest than the entered value. So 0 is the smallest element of the entire sorted list and 7 is the highest element of the entire sorted list, and all intermediate elements are on specific position. Ultimately we get all the value sorted. That means this one is all called as unsorted list. And after pass number 2, we'll get our sorted list. And the strategy that we have done, that we have implemented in this particular number is called as selection sort. Even into the theory of selection sort, it further contains the detailed discussion like selection sort is an in-place comparison sort. So selection sort is also known as comparison sort also. So keep in our mind, into the examination, the question might be like this: what is comparison sort? Explain. So ultimately it's a selection sort. Don't get confused. So selection sort is also known as comparison sort, and as far as the complexity is concerned, it uses big O and 2 complexity, making it inefficient on the larger list and generally perform worse than the similar insertion sort. Selection sort is noted for its simplicity and also has the performance average over more complicated algorithm in certain situation, which says that selection sort is much easier than the other sorting technique which we have previously learned. Selection sort is famous for its less complexity, easy to implement, but it has our limitation that on the larger list of element, this selection sort will not perform the sorting of the numbers. So just keep in our mind, for the less number of elements, selection sorting technique is better and fast for sorting the numbers. Now let's see the algorithm of selection sort. Algorithm of selection sort is mentioned onto the screen, where it contains of 8 separate steps. Step number 1 is actually the initialization of various variables like current equals to 0, which shows the current position of element, and size is equals to number of elements. As far as our practical is concerned, Over here we have entered 5 unsorted elements. So this 5 is mentioned by the size, and the first element called 5 is represented by current. Now once the initialization is done, in step number 2, it actually repeats step number 7 while the current is less than the size of elements. That means for all other elements then the current, a one looping control statement will compare all the elements. Means if you remember, then I have compared 5 with 0, 1, 3 and 7. So that could be done using this particular step number 2. Now step number 3 is actually used to move the internal pointer to the various position. That means once 5 is compared with 0, 5 need to compare with 1, then 3, then 7. So for that, step number 3 is written J is equals to current plus 1. Step number 4 is what? Repeat step number 6 while J is less than size. That means this current is incremented by 1 till all the valid elements of the entire list. Say for example, we have 5 elements, so 4 repetitions are there. Suppose we have 2 elements, then 3 repetitions are there. Suppose we have 3 elements, then 2 repetitions are there. And suppose we have a 1 element, then by default it is the highest value of the entire list. So that can be observed by this step number 4. Step number 5 is if area of current is greater than area of J, that means during the comparison, if any of the element found to be smaller than previous one, again I am repeating my word and listen it very carefully. During the comparison of elements, if any of the elements found smaller than the previous one, that could be replaced with that particular position using the swapping logic called temp equals to area of current. Area of current is equals to area of J, and area of J is equals to temp. It's a general logic of swapping the number. That means this 0 is replaced with 5 and 5 is replaced with 0. So that could be done using step number 5. Step number 6 and step number 7 is actually the repetition of previous step called 4 and 2, which increments the positioning of the current value, and ultimately whenever we reach at step number 8, all the numbers get automatically sorted. So now let's implement our program using this particular sorting technique called selection sort. Obviously, into the implementation of selection sort, we will use the concept of user defined function, and the type of UDF is function with argument without return value. So what will be the definition of program? Write a program to implement selection sort. So just note down this particular definition first. Write a program to implement selection sort. I hope or if you have noted down this particular definition, and if it requires you can also note down this algorithm also, but it's already there into the books, no need to write it. So let's start with the program. This is the code. It contains of only 36 lines. Let me show you the output directly. I am just compiling the code. There is no syntactical error is there. Just execute the code. My selection short program selects my selection program sorts only the 5 unsorted values. The limitation of this particular program is that it sorts only the 5 elements. So I am entering 5 unsorted values. Say for example 4, 2, 0, 1 and 9. These are my 5 unsorted values. Again I am repeating my words. This particular program only sorts 5 unsorted value. Once you compile and executes, we have to enter any 5 unsorted value. I have entered 4, 2, 0, 1 and 9. Once you press enter, it sorts all the value and displays a sorted list onto the screen like 0, 1, 2, 4 and 9. All these are the sorted value from smallest to highest. Now let's see this particular program on Notepad for better visibility, because in Turbo C, in a recorded lecture, you found some difficulty for visualizing the program. So I am opening this program into the Notepad. So this is the code. Let's try to get each and every line properly. First two line of the code is the initialization of necessary library functions, that is stdio and console input output.h. Then there is a function prototype. In function prototype, my return type is without return, so there is a void. Name of UDF is selection underscore sort, and I am passing the two parametric values, where first is the array and second one is the size. Then into the void main statement, 3 local variables I have declared, that is temp, current and j. If you remember, then in our algorithm the same variable name we have taken, that is current and j. Then there is a CLR, ACR and one loop. Into the loop, variable called current starts with 0 and it repeats less than the total size. That means 0 to 4 times total it accepts the 5 numbers. During this repetition, another child for loop where there is an initialization of j is equals to current plus 1. Actually this is the step number 3 as per as our algorithm is concerned. Let me take this algorithm again into the Notepad. I have removed. Let me copy paste it again. Make it proper. Give proper alignment so easily we can visualize. In this algorithm, in step number 3, you can see that I have written j is equals to current plus 1. So The same thing is written over here. J is equals to current plus 1. J less than size J plus plus, that means J repeats less than the current position of the element which is available into the array. Now during this repetition, my step number, so this loop is this one, J less than size. Over here just observe J less than size is there, and in my program even there is a J less than size. So this is step number 4. Step number 5 compares and interchange any smallest value than the previous one. So for that, this logic is written: if array of current is greater than array of J, temp equals to array of current is equals to array of J, and array of J is equals to temp. The same thing is written in my step number 5 of an algorithm. Fine. So ultimately this will sort all the numbers. But how this sorts the number? By passing the values. So we can write a void main statement with opening and closing bracket. In that I have declared a one variable called values of 5. That means, as I have already instructed you, my selection sort only sorts 5 unsorted value, and there is a declaration of the variable called I. Then there is a CLRS here. The message is there: printf enter 5 elements for I is equals to 0, I less than 5, I plus plus. 5 elements get read from the user and it passed into the selection sort. Selection sort, that means this portion sorts all that 5 numbers, and the response came back into the void main statement. Void main statement have a one for loop which print all the sorted list. Just put this void main statement before this selection sort. So there should not be any doubt. Let's save this code. I would like to recompile it into the C. So there should not be any confusion. Let me open this one again. See, the sequence of void main and selection sort is as normal as we are doing. I am just compiling. Type mismatch in redeclaration of selection sort. What happened? Let's remove this. Integer and size. What's happened? Values goes in this array and this size goes. Type mismatch in redeclaration of selection sort. Type mismatch. Okay. Integer and integer. Let's write over here like this: void selection sort into the bracket integer comma integer with semicolon. Save it. Oh my god, 2 errors. Selection sort. Okay, I got the solution. Let's compile it. Let's enter any number. Number gets sorted. Fine. The thing is what? Don't interchange the placing of void main statement. Just keep as it is. Let me show you again. That means first initialize your UDF and then write down the void main statement. This might make the mistake. This is something new even for me. Anyways, just note down the program. This is the correct program. I have already executed, entered, and show you the shorted list also. So just pause the video and write down these selected lines carefully. Again, I am repeating my words. Just pause the video and write down these selected lines carefully. Again, pause the video and write down remaining selected line of code. Again, I am repeating my words. Again, pause the video and write down the selected line of code. Fine. I think all of you have written every line very carefully. Watch each and every line properly and as mentioned onto the screen, note it down into the journal and then try to execute the code at your home. I know this is little bit difficult to digest all these things on a virtual mode, but still in this panic situation there is no other option. So I hope all of you have understand the selection shot, its theory, its algorithm and its program properly. Thank you very much students for listening me and have a nice day. In our next lecture, we'll go for the last sorting technique, that is shell sort. Till that, thank you very much for listening me.